Hi, my name's Clark Harshbarger, and I work with Mad Agriculture.
My job specifically is to work with farmers, help them understand their land, and support them on their journey to regenerate their farm.
How did you get into soil? What piqued your interest or curiosity in it?
I've studied soils my whole adult life, and I think there was two major events. My grandfather on my mother's side was a farmer. So as the summers went by and as I got older, I would just remember one time working a fence line with him. As we went up the side of the hill, I just remember the soil colors changing when we went from the lower position on the land to the higher position on the land. And as we went deeper, they would change, and sometimes they would get cooler, from the top of the soil to the bottom. And I think that was the first, earliest germination of oh, this is interesting. And then many years later, when I was in college at Montana State, I was trying to get a degree in horticulture, and one of my classes was soil science. At the end of maybe the first or second week, he said, does anyone want to go to Oregon this weekend? If you do, stay after class and I'll share the opportunity with you. And I, being from Ohio and going to school in Montana, had never gone that far out west before. And so I said, that sounds really great. So out of 300 people, only 2 students stayed after class, me and my friend Emily. And he said, hey, we have this thing called a soil judging team. We need new students to be on the team. And if you want to jump in the van, we're going to go over. And so I jumped in the van. And from there, I think I switched majors and, traveled to Asia to learn about soils. And I've been to every state besides maybe Alaska to look at soils. And I think it's something that I've always just been naturally curious about. We always say, when you see a soil, there's not always a perfect answer. It's a lot of what we call a working hypothesis. So it allows everybody to have an opinion and for everyone to collaborate to try to solve a problem. And so those are some of the things that brought me into soils and why I've stayed in the field, because it's kind of an art, creativity to understand some of the things, and that, there's still just so much to learn about it. Everywhere you go, the soils are different. So that's what makes it really fascinating, is if you're at all curious, you can move around, you can learn different cultures, you can be in different countries. And if you have that as a way that you can offer professional expertise, it's always going to be challenging yourself, but you're always going to be able to add something really invaluable to communities if you can help them understand how to care for the soils.
The main piece I want to talk to you about today, which is that we're doing a lesson on soil and how it's so important to plants and crops and the foods that we eat, and specifically thinking about how soil gives nutrients to plants. And we're focusing in on nitrogen. And I was hoping you could talk a little bit about why farmers need to think about nitrogen.
The air that, all of us are breathing in, our atmosphere, is made up of about 78% nitrogen. So we go through this very complex understanding of why is there so much nitrogen in the air, but then our farmers can oftentimes be deficient in nitrogen. And instead of in nature, those plants staying in the soil, like in a grassland, the grass is there, maybe a bison would eat it, and then they would defecate out their waste through manures, and it would go through a cycle and stay in place. But when a farmer raises the corn, for instance, they take the corn and it leaves the farm and comes on to our tables. And so they're removing some of that nitrogen out of a closed cycle. And so the farmer, once they remove that nitrogen, they know they have to supplement some nitrogen. So if you test for how much is in your soil and you account for how much you're removing, it leaves you with a simple equation. You have 10, you remove 7, so now you're down to 3, and you want to get back up to 10 pounds. Well, corn, for instance, has an old rule of thumb that 1 pound of nitrogen equals 1 bushel of corn. And so if you have about 100 pounds of nitrogen in your soils test, the farmer can estimate. It depends on rain, and it also depends on other fertility items and what species of corn and where you are with how hot you get in the summer. And there's lots of other factors. But the main point is that you can account for 100 pounds of nitrogen will give you 100 bushels of corn. So if you have 100 pounds and you get a 90 bushel harvest, you say, well, I might have about 10 pounds of nitrogen left. I'm going to have to really I'm going to have to buy a lot of nitrogen.
You mentioned there's a general number sense of how much nitrogen a corn plant is using. Mm-hmm. Do we know for like other plants, like, I don't know, a tomato plant, do we know how much nitrogen a tomato plant is using? And is there a big difference in plants?
Yeah, the size of the fruit typically will correspond pretty similar to the nitrogen that they need, whether they're a root crop or a fruiting crop, like so potatoes and carrots and some of the tubers that we eat the roots of typically can use less nitrogen. Another crop that is being grown more and more that's a great scavenger crop is buckwheat. Buckwheat can survive off really low amounts of nitrogen, and it's because it has a very small seed that we utilize. The grains are about maybe half as much. So the common grains that we eat, like wheat and barleys and rye, will take anywhere from like 50 to 60 pounds of nitrogen, where, like I said, a corn plant might take 100 pounds.
So a lot of that comes back to the architecture of the plant leaf. Sunflowers and corn both have really big, broad leaves. And so it takes a lot of nitrogen for that plant to just create its characteristics, big, broad leaves, where wheat, as we know, has a very narrow leaf compared to a corn leaf. And then the actual grain head is much smaller than a corn plant.
The beauty of that is that you can use other plants that don't need as much nitrogen in a thing called crop rotation. So the most common crop rotation in the Midwest, of course, is using corn and then following that with soybeans, which are a legume, which can actually source their own nitrogen. The legume plant is famous because have a relationship with a bacteria called rhizobacteria. The rhizobacteria will actually go through the soil environment into the plant and will create basically a growth inside the plant. And inside that growth, the plant will provide sugar that the bacteria needs. And then in turn, that bacteria can take the nitrogen gas from one form and then turn it through its body to a form that's then available to the plant. It's called nitrogen fixing.
And if we only harvest like the bean pod for soybeans and we leave a lot of the plant tissue and residue, there can be an additional amount of nitrogen in that tissue for the following crops.
And if we look at almost every ecosystem, from the tropical rainforests to savannas, to the Great Plains and the prairies, there's a legume in every single one of those. And that's why in healthy ecosystems, there's lots of different species of plants. A healthy prairie could have had anywhere between 25 and 30 species of plants living in it at any one time.
As you go through these crop rotations, you can think about what other crops can I put into the system to allow the crop rotation to actually give something back to the soil. And so legumes are really important. In South Texas, in the Rio Grande Plain, you can grow guar or peanuts. In the Midwest, we grow typically, like I mentioned, soybeans. And in the Great Plains, they can grow any of the dry beans like pinto, black beans, light red kidney beans. And there's many different species of heritage beans that have been forgotten that we're trying to remember more about and put into our cultures and our local restaurateur businesses. So that's something that we're really trying to encourage at Mad Agriculture, is to create that whole food system where everyone can participate in this solution. By choosing what you buy at the grocery store can really help the farmers be more secure in planting more diversity in their crop rotation. Farmers markets have been one way that we've actually seen farmers be able to grow different crops. We've also seen that show up in the resurgence of bread. There's been a lot of artisan milling and bread bakeries where you can get bread that's actually from a farmer that you can see a picture of on the walls in the restaurant or in the bakery. So I think it's so important to try to keep using our creativity to try to solve these problems together. Everything is connected. Our soils are connected to our water, it's connected to our air. And so that's why it's really important that we find solutions that everyone can participate in.
Well, thank you so much for your time, both today and all the other times that we've chatted. I really appreciate it.
Yeah, you're welcome, Kate. And there's lots of resources out there that I think I've shared too. So if you want to take a deeper dive, I strongly encourage it. And the best way to learn about soil is in the field. Gotta get your hands dirty.
Yeah. Thank you.
You're welcome.